Hi, the video that you're about to watch includes all of the demonstrations that are required for the activity accelerating reactions. Remember, for each of the demonstrations, there's 5 total. You guys are going to be writing down in your data, your observations. First column, what do you notice? Basically describe what you see happen. Number 2, what does it remind you of? Please think of something outside of class that this is reminiscent of. The third column, what do you wonder about? Think of a question that maybe pops into mind or has something to do whatsoever with the demonstration. And then the fourth column, what's a possible reason or explanation? Either provide a possible answer to the question you just asked in the third column, or a possible explanation as to why the phenomenon that you're witnessing actually occurs. All right. Now, the first demonstration that I'm going to be showing you is the one called dragon breath. Okay. Let me adjust this. There we go. All right. So first of all, it involves this substance here. It's called lycopodium powder. Now, lycopodium is a small single-celled organism that actually has very flammable properties if done correctly. I'm going to show you this by taking a small amount of it and putting it in a pile on this watch glass. In order to get it to try and burn, I am going to use this Bunsen burner. I'm going to light it and try to burn it. And unfortunately, it's getting a little brown, a little blackish, but as you can see, not a whole lot going on, okay? However, when I take that same substance and spread it out using the pipette, we get a bit different reaction. If I take this, pull it out, we have a bit different of a reaction, okay? A much more explosive one. Hi. The next demonstration I'm going to show you is called glow sticks. It involves a couple of glow sticks. I'm going to start each one. Now, shake that one up, shake this one up. As you can see, both glow sticks appear to have very similar gradients. And remember, the brighter the color, the faster the chemical reaction is. I have here 2 beakers. One has ice water, the other one on this side has hot water just out of the kettle. So I'm going to put both of them in. We're going to let them sit for a second. Actually, for about 20 seconds. Yeah, this part's kind of boring. Now, we hold them up to each other. The one over here that was in the hot water appears to be a bit different than the one here that was in the cold water. Okay. Keep them in a little bit longer. You can actually watch that while I go through the next demonstration. The next demonstration is called cheap cannon. Now, for this demonstration, I'm going to be using this right here. This is ethanol. Ethanol, it's actually a 95% solution, which is about a 190 proof alcohol. I'm going to take a small amount of it. I'm going to just put a few drops there. And I'm going to light it on fire. As you can see, it has a nice, steady burn to it. And just to finish off this one, while that one's burning, here you can see a much more marked difference between the two. Again, in the one in the hot water, the one in the cold. What I'm going to do now is I'm going to switch them. I'm going to put the bright one into the cold and the dull one into the hot, and see if we can see a difference in just a few minutes. All right, as you can see, that has burned all the way through. Took a while, nothing too exciting. Now this, we're going to try the same reaction, but this time using this. This is what I call my cheap cannon. It's simply a couple of tin cans duct taped together. The top one has both sides open to make one long cylinder that is closed at one end and opened at the other. It has a touch hole at the bottom, a hole punched all the way through. I am going to take my ethanol and simply squirt a little bit inside. Not a lot, just a little. And then I'm going to cover it up with this, which is the cap off of a tube of tennis balls. And I'm going to cover up the touch hole, plug that up on top, and then I am going to coat the inside with the ethanol. Then, make sure you can see this, I'm going to light. And that is my cheap cannon. Going back to this demonstration, again with the glow sticks, remember I switched them, and now the one in the coal that used to be brighter is now a lot duller than the one that was in the hot. So that is those. All right, now the next demonstration, I need to have it light again. Then it's called Elephant's Toothpaste. 1 second. Now in this one, it involves this right here. This is hydrogen peroxide, H2O2. It undergoes this chemical reaction here. I don't know if you can see that well, but it undergoes a degradation. H2O2 becomes H2O and regular oxygen. Now normally this reaction occurs so slowly that you cannot really see it. All the oxygen that is produced gets dissolved in the water and doesn't actually bubble or anything. Now the solution I'm using here, this is a 30% solution. The normal store-bought hydrogen peroxide that you would have is a 3% solution. So this is a bit more concentrated, 10 times as much. So I'm going to first of all take a small amount, approximately 20 milliliters, and as you can see, no bubbles. Now, there is a substance inside our blood that speeds this reaction up. Hopefully you know if you ever put hydrogen peroxide on a cut, it starts to bubble and foam. That bubbling and foaming is simply this reaction sped up. So now I'm going to take that, I'm going to put it into this larger graduated cylinder. Again, really no bubbles. To illustrate this reaction to make it a bit more obvious, I'm going to take some dish soap, pour a bit in there, and then I'm going to take a small amount of this solution here, which is a 2 molar solution of potassium iodide. And measure out a small amount, approximately 2 milliliters. Then I'm going to put it in here. I don't know if you guys can see it, but it is giving off steam. This is quite warm. It's an exothermic reaction, and is obviously sped up to a great degree. All right, so that is the elephant's toothpaste. And the final reaction, the final demonstration, this one again works best in the dark. Turn off the lights again. And put this guy aside. This one involves, once again, our old friend ethanol. I have in this tray simply some water, and I'm going to add a little bit more ethanol in there. It's approximately a 50-50 solution. So I am going to pull out a $20 bill. Normal $20 bill. In every regards. I'm going to put it into the solution. Get it thoroughly coated. And then yet, those seconds ago, it was completely in flames. It is still sound and intact. Blazing paper.